Well, hello, Jax. It's great to be here. I feel warmly welcomed to Mainz. I got to meet several speakers at the welcome reception last night, which took place, I guess, down the river a little ways at a winery. And I even got to use some of my rudimentary German skills trying to listen to the winemaker explain winemaking in the region. But sadly, I can only catch a few words. It's been a little bit too long since high school German. But it's great to be here. As you just heard, I've been working in the cloud and container open source ecosystem on behalf of IBM for a number of years, about 4 or 5 years. And I think it sounds like it. Hopefully what I'm going to share with you this afternoon matches up with some things you've already heard today. Just about the fact that even if you're a Java developer for an enterprise, maybe in years past you could just focus on your application, just write your application. Let's not worry about the infrastructure or the delivery method. But really it's becoming, in sort of the DevOps world that we live in, it's becoming much more important that all of us understand kind of the layers we sit on. And as more and more, technology buzzwords come at us every year, I think what I'd like to try and convince you of is that these, at least the 4 I'm going to talk to you about today, actually matter to developers and to the enterprises they work for. And hopefully I can convince you of that. And if not, I'd love to hear your thoughts afterward. So obviously, in 30 minutes, we can't really cover every possible variation of what enterprises are looking for. But as I've grown in my career from, working sort of deep down in the software and the plumbing, in fact, many years ago at IBM, when we first got involved in creating a JVM for IBM, I actually worked on the JVM for OS/2, which is a long forgotten operating system from IBM. But at the same time, we also brought Java to Linux. And I had the enjoyment of actually being one of the first people to port the JVM to Linux back in 1999. The version numbers were much smaller then. I was working on JVM 1.1.6, if you can believe that. So it's been quite a while. But as I've grown in my career, I've had to start speaking to customers, not just working on code. And you start to see that there are themes that come up, that there are a set of common problems that people are trying to solve. And so I've picked 3 of them. I think they're representative. And really, out of that, hopefully we'll look at how these technologies apply to the 3 specific areas that I'd like to talk about. So first of all, there's this whole concept of speed, of developer agility, of trying to move faster. And in some sense, enterprises have had a history of moving too slow or having this monolith that's hard to update. And there's even been maybe a bit of envy at the startup culture, the move fast and break things of the Facebooks or Airbnb or Netflix. And so there, as these worlds have sort of collided in open source, there's been an interest to really tighten that cycle between developers coming up with new features and bringing that to a market or bringing that to their customer. And so speed, I think, is one critical thing that enterprises are trying to solve today. In addition to that, security is a huge topic. I'm sure you're all aware. There used to be a saying, no press is bad press, or conversely, all press is good press. But there are certain headlines that you don't want to be a part of. And so, the Equifax data breach, that's not a headline that the CEO of Equifax or the CIO wants to see. Facebook had a massive security breach a few years ago as well, and obviously showed up in the headlines. Or Marriott, and these are just extremely large ones. These are not an exhaustive list, obviously. If you look on Wikipedia for breaches, there's huge lists. 2018 probably has 20 or 30 breaches that are known and published. And so again, security is a huge area where enterprises don't want to wake up one morning to a headline that they have been subject to a breach. And then lastly, the third area I want to talk about is efficiency. And this is kind of a combination of several different areas. You know, enterprises care about the costs, whether it's labor costs or infrastructure costs, or even the portability of being able to move clouds, or to not be stuck with a certain vendor and have vendor lock-in. And so again, if we think about it, enterprises are trying to solve an efficiency problem of lowering their costs and being agile in their own way of being able to move workloads when and where they want to. So really, when we think about, you know, cloud or containers or microservices, you know, are these just the next set of unicorns that everyone, you know, hears about at conferences, that, you know, blog posts are written about, and there's a hype cycle. You know, we see these curves of early adopters and lots of excitement and big conferences. Or are these real solutions to enterprise problems? And so for the next few minutes, I'd like to try and take each of those three problem areas and convince you that there are actual solutions found in each of these areas for the problems we just talked about. So let's take speed first of all. And so with containers, and again, this is the area I've been working in significantly the last few years. How many projects do you see out there that have a Docker file? If you go to an open source project, it's packaged in a container, it's delivered maybe via Docker Hub or another registry and available for others to use. And these images can be very small. The build time can be very fast. There's a lot of developer simplicity to consume this now, because if I can take someone else's Docker file and build on that, and so it lowers my iteration time. I'm actually curious, how many people are using containers in some way already today? Yeah, so these lights are bright, but I think I saw maybe half the room at least. So again, containers are bringing an answer for that speed issue. The area of cloud, obviously you hear anecdotally, you know, companies complaining about, it takes me 6 weeks to provision or get approval for a new VM or a new server. And so the possibility and the potential of, for example, public cloud, of being able within minutes to spin up a VM or to use managed services. So instead of telling a set of developers, go figure out how to bring up a cluster of MySQL nodes and handle all the issues of redundancy, backup, etc. Or I can go to a public cloud and pay for that as a managed service and let someone else figure out and solve those difficult challenges. And again, serverless has become quite popular as well for some of the similar reasons, that I don't have to think about even how many servers to bring up or how to scale those servers. And so I can let someone do that for me. And so in that way, cloud and cloud offerings are bringing solutions for the speed problem. In microservices, you know, Amazon popularized the idea of a two-pizza team, the ability to iterate quickly on a small team and to bring, again, cultural changes as well, so agile and other lifecycle and DevOps improvements through the use of microservices. And I think even here at this conference, you can see talks and workshops on these concepts across the conference schedule. And then with open source, obviously everything has both a positive and potential negative side. You know, the pace of innovation in the open source world can be almost furious at how quickly things change, which can be hard for enterprises who've been used to long release cycles or stable APIs. But yet also the pace of innovation brings a lot of new capabilities. And going to an open source project, you know, we find there have been interesting reports over the years of how quickly a problem can go from reported to being resolved upstream in an open source project. Again, can solve some of those issues that have nagged enterprises in traditional development models. So again, in all these ways, the speed problem is being attacked and being solved in these specific ways. So let's talk about security. In the container world, again, the area I'm most familiar and have worked the most in, isolation primitives. And so the very fact of how containers work are isolating that piece of software from every other piece of software on that, Linux server or Windows server. And by default, you're getting improved security just by nature of using containers. And so in the Docker world, there are several things that just happen when you start a container. An AppArmor profile, which is a feature of the Linux kernel, is applied to the programs running in your container. And I would guess, unless you had a very specific requirement to do so, when you've written software over the past 5, 10, or 15 years, it's highly unlikely that you took the time to go write an AppArmor profile for the Linux kernel specific to limit your application to do only certain things on the host. And so again, by default, you get that when you're running in a container. Seccomp, secure computing, another feature of the Linux kernel. By default, when you start a container, a Seccomp profile is applied to your container that limits the system calls that your container can make. And again, so these are ways you're automatically getting improved security that you're not having to write. Your developers aren't having to write that. And it really enables a whole ecosystem of secure tools. And so by nature of the ecosystem that's come up around the container industry, so Twistlock or Aqua Security or Snyk or other third-party add-ons that do things like container scanning, or even look at your Docker file or other parts of your deployment and notify you about weaknesses in your security. All this is coming through the adoption of containers. And then when you add cloud to that, almost every public cloud is trying to attack the issue of working in highly regulated environments, so governments and banks. And again, these teams of people at public clouds are solving things that would be very hard for you to solve on your own. So things like FIPS or PCI compliance in the USA, or SOC 2 for data center compliance. And so these are challenges that are being solved for you, and when you adopt cloud, you get these by default when you're using these cloud environments. If you've looked at microservices in the container world, Service Mesh, another popular topic. IBM's involved in Istio, the open source project. And again, here, instead of your application developers having to write SSL termination code or certificate rotation implementations, these service meshes are providing that for free. So you're deploying your application as a microservice, you give it network policy and access rules, and these service meshes maintain that for you. And so you're automatically improving the security by making sure that service A should never talk to service B in this way or through this channel. And you're getting mutual authentication over TLS because of that. Finally, talking about open source and security, it was a common myth many, many years ago that open source couldn't be as secure as commercial code. That, you know, it's out there, it's public, how could it be secure? But many, many aspects of research and papers that have been written have dispelled that myth for quite a while. There's also great projects like the Linux Foundation's Core Infrastructure Initiative. And this is to make sure that common pieces that we all rely on, like OpenSSL, that the maintainers are paid and that they have all the resources they need to test and release software that's secure. And so again, open source is even providing us better security because of these initiatives. Finally, let's look at efficiency, again, across these areas. And so one of the ways that container technology brings about efficiency is just this software packaging efficiency. Container images have now been standardized. The Open Container Initiative has taken what Docker initially created and made a default standard out of that. And so everyone's using that, whether you're using, Red Hat's OpenShift or Kubernetes or a specific public cloud like IBM Cloud Kubernetes service. You're able to share content and images and Docker files across all these platforms and tools and get the efficiency of that, and also the efficiency of what we already talked about with speed and containers, maybe more deployments per server because your container images are smaller, more lightweight, costing less resources in CPU and memory. And so when we talk about the cloud, again, cloud providers offering you auto-scaling out of the box or serverless or giving you those choices. You can request a VM and you can install MySQL or some other service or Kafka and manage it yourself. Or your leadership can look at the costs, can make a comparison and decide between self-manage and manage. Again, giving you options and the ability to choose your own path. Again, with microservices, the idea of reuse. Basically, my services are now smaller, manageable components with hopefully clean API abstractions. And now I get more efficiency because I can reuse them across, different sets of services. And finally, the whole notion of open source, the fact that we all get value from something a small set of people are working on. And the improvements to that open source apply to everyone who consumes it. There's an interesting study that the Linux Foundation did several years ago. I think it's actually been almost a decade now. So I don't know what would be in today's dollars. But the development time that's been invested to just create the Linux kernel, I think they estimated $1.8 billion of US dollars in cost. To create a Linux distribution, like maybe the size of Fedora, the estimate was, I believe, over $14 billion. Again, just taking developer time. And so again, you can see that that's a cost that you don't have to pay when you consume open source. So if you're talking about Docker or Kubernetes or Istio or any of these pieces that are being maintained and created by small communities of open source contributors, whether they're independents or from enterprises like IBM or Google or Microsoft, you're getting the efficiency of all those improvements given to you when you consume open source. So hopefully in those three areas, I've given you some solid information that, these aren't just, something for the latest fad and hype cycle, but they're actually useful to solve the challenges of enterprises. But hopefully to back that up a little bit, a few examples from actual customers of IBM. For example, this bank, these are actual quotes that they provided. We want to bring apps to market faster. Again, that idea of we want to be like a startup to move quickly. And running in a managed environment means that we just focus on our applications. So we don't have to spend developer time and cost to try and maintain an environment ourselves. American Airlines has been a longtime customer of IBM. But again, they're also moving many of their applications to the cloud, to Kubernetes, to Cloud Foundry. And so again, leveraging open source is important to them to combat vendor lock-in, but also even the organizational side of it. So I've talked a lot about technologies, but obviously there's a cultural aspect to all of this. So, moving to processes like agile methodologies, or applying DevOps more specifically within your organizations. And so all that's involved. Obviously, we have many other customers. And one other I wanted to highlight briefly, just because it's been an interesting contrast of both making the headlines, but also out of that, making some significant changes. So Maersk Line, you may have heard this very interesting story in Wired about the malware that entered their network, I believe through a laptop, and had disastrous consequences internally at Maersk. It traveled through the network. I think in the end, this is a very interesting story if you haven't read it on Wired. I think they had to re-image over 4,500 systems as a result of this. and had huge business results or business impact in the amount of money lost in all the goods that they're delivering around the world, and how important it was to have access to their systems. And so out of that, they've created an initiative called Maersk Always On, where their intention is to automate everything they can automate, to adopt cloud, to be platform agnostic. So again, building on Kubernetes with containers, to do this in a disconnected mode, from the corporate network. Again, part of the issue of the malware was all these interconnected systems, and then distributing clusters worldwide that allows one area to have an outage without affecting the entire company, and to start generating API economy across their company. And so hopefully from that, you can see that real enterprises are finding real value. And it's not just our customers, IBM ourselves are adopting and transforming. Obviously, we're a very old company. We have software from very traditional aspects of our business, even to modern pieces that are built on Kubernetes. And so we're, in effect, replatforming ourselves with a containers first and container specific initiative. So you can see here things like Watson, artificial intelligence, those APIs, those engines are all running on our Kubernetes service. Our Cloud Functions, which is our serverless project, is also running on Kubernetes. Our Weather Company APIs and that whole back end, again, running on Kubernetes. And so out of that, we've built a unified container platform that, as you can see, every level of it is built around open source. And so I can say I'm pretty happy that the project I work on underpins that. Containerd out of the CNCF that was mentioned in the intro. That's our chosen container runtime that Kubernetes runs on. Istio, the service mesh, sits above that. We've gotten involved in Knative. OpenWhisk is the open source project that sits on that with our IBM Cloud Functions and our Cloud Foundry service. And again, we have partnerships across the industry, so LogDNA and Sysdig. And then, of course, you can bring any runtime to that. So whether, MicroProfile or Spring or Golang can sit, and you have choice across these runtimes and across these platforms. So again, that's something we're doing internally, and we don't just do that for ourselves. We have a very strong open source focus within IBM that I took just the Docker project, Containerd, the OCI, and Kubernetes, and out of that found 77 people across IBM who contribute to those projects. And I think there's only about 50-some photos that I can fit on the screen. If you want to write a really cool app, find a way to take photos and make a slide, because this is really time-consuming. I was hoping there'd be software out there somewhere to do it for me. But again, IBM's mission is to give back. And so, again, maybe you've heard of our Red Hat acquisition. Hopefully we'll just strengthen that, our involvement upstream and contributing upstream. So really, the last minute or so, I'd love to really call each of you, what are you doing with these technologies? Are you solving problems with speed, security, and efficiency with these layers? And if not, is there feedback that you'd love to give to me or to upstream communities about what's missing and what you would find valuable? So the rest of today, I'm going to try and stick around the IBM booth. I'd love to meet you there, talk to you. We have some Java experts that are here. We even have someone from the J9 team, I think, speaking later this week. There's a great open source project that some of our folks here in Germany have built that will help you start to, if you're a Java developer and you're like, I don't know how to start with these technologies, containers or service mesh. These folks can show you this open source project. You can start building on it immediately. It solves real challenges. It's not just a Hello World app. So again, thank you for your time. We'd love to see you there, and thank you for listening.